you're supposed to.
The card's full, so.
Gotcha. You're supposed to also you're supposed to.
It's a list of tasks.
Right. Yeah. A list of tasks. So you can think of each of those tasks you have to do as something called a callback.
Okay.
Because I'm calling back to the list, like I have to look at the list.
Yeah. I don't know exactly why it's called callback.
Okay.
It just is.
Okay.
So someone could modify the list of actions you have to do. They could add another callback, or they could remove a callback.
Callback is is a task.
Yeah.
Yeah.
In our
My
case,
list.
in programming, it's a function that gets run.
Yeah.
So we can pass. So our class subscribable core, it has a function called onUpdate. So let's say the message you received on your desk. Let's call that message an update. So it updates your work schedule.
My day or whatever.
Yeah, your day. Every time you get a new thing on your desk, that's an update. And based on that update, you have to run a list of tasks, a list of callbacks. You have a method called onUpdate, and it takes a function, or rather, we'll call that function a callback, and whenever onUpdate is called in our object, we add that callback into our list of callbacks. Meaning, there are two functions. So
That's okay.
one is called update, and one is called onUpdate.
Okay.
So let's call this function receive and update.
Okay.
So when our object gets receive update called in it will execute all of the callbacks. And each of the callbacks will receive the update object, and each of those callbacks will perform based on what the update object is.
Yeah.
So let's say a piece of paper, that's the update object given on your desk. It might be different colors. So let's say if update object.color is green.
Yeah.
When you go to the kitchen, you make tea instead of making coffee. So it kind of determines our callbacks.
Yeah. So these are callbacks are like these general tasks, and then onUpdate is like kind of how you run those tasks.
Yeah. Well, no, onUpdate doesn't run the task. It adds another callback to the task.
Yeah.
So every time you call onUpdate with another callback,
it's just a function within a function.
It'll add another callback.
It's like x plus y equals z, and then it's receive update, and you plug z in, and so z is equal to x plus y. You know what I'm saying?
I don't understand that.
So here, this is just how this is basically receive update. Okay, so receive update, and then in parentheses is update object. I'm just renaming that z, and then update object. So z is a function of x and y.
Okay. What are x and y?
Just random, just like I'm kind of like it's an analogy to like math. You know what I'm saying? Like this is a function. This is the variable. Okay. You know what I'm saying?
Yeah.
It doesn't matter.
Well, I think you might have something to it. So.
Okay.
If we're calling, so you said z is the update object.
Yes.
All right. So let's call each of our callbacks A. B, C,
update object
G,
and onUpdate.
So let's say we just onUpdate, we just pass in G.
Yeah.
So we're saying that let's say our object is called obj.
Yeah.
Or no, let's call our object.
Okay, wait. Question: update object versus onUpdate.
Right. So update object is the name of a parameter in our receive update method.
Okay.
Two methods.
Yes, it has to follow update object, like the type. This is the parameter.
Yes, this is not a type.
It's a requirement or something.
This is just this is a parameter we pass into a function.
Okay.
Just how in f(x) you pass action to the function.
Yeah.
So we're going to introduce a concept called this. This is a reference to the object that this class is behaving under. So, in programming, as you may have picked up in the past few days, we have things called objects. So let's name one of our objects Brian. Brian might conform to the person interface, right?
Yeah.
So we could say Brian, we'll say const Brian. He's a type person.
Yeah.
actually the way we've been coding is instead of saying person, we say I person. Have you noticed that? So the I person interface,
I means that.
it just stands for interface.
Yeah,
That's
okay.
a prefix. So we could write interface I person, and then we could give it one property height. Height is going to be integer, and inches. Or sorry, it's going to be number. That's the way you type it in type in TypeScript. And then we would have a method called jump.
Yeah.
So,
Method is a function.
yeah, function. Yeah. So functions.
It's more common to say method or function.
It depends on the context.
Okay. That's
So
fine.
functions that are part of an interface that an object conforms to get called methods.
Say that one more time.
Functions that are part of an interface that objects conform to are called methods.
Okay.
Or rather, any function that is attached to an object is called a method. So we can say Brian.jump. Jump isn't called a function in this case. It's called a method because the function is like part of the Brian object. It's part of the person class. But really, we don't have a person class here. We just have an object that conforms to the I person interface. I don't expect you to understand what class means yet.
Okay. Yeah.
But anyway, so what I was getting at is that Brian. Okay, so here we're going to introduce a concept called classes. I've thrown a lot at you. I'm sorry, not new class. It's a new person. So, person, that's a special type of function called a constructor function.
Okay.
And person is going to take two arguments. It's going to take one argument, and that's going to be the height in inches of the person.
Okay.
So that's
And it must be a number.
Yeah.
Because this is Brian. Brian is this is an interface, and then this inner interface there's height, and it needs to be in a number, and then
right. So that's what we'll be getting at, but we actually haven't defined the person class.
Okay.
So whenever we create something called a class, it creates something called a constructor function for us. I don't know if you can see this. So we can, in TypeScript, we can type something called class person, and then we can write out something called constructor, which creates something called constructor function. And this function, we are going to define it to have one argument, and that argument is going to be height. And height is going to be of type number. If someone were passing a string here,
Okay.
it would throw an error.
Yeah.
And then, this is what it's getting at. We're going to introduce a concept of something called this. So we're going to say this.height. Actually, to reduce ambiguity, we're just going to, let's say state characters are related type. We're just going to say H.
Okay.
Right? You can name variables whatever you want.
Yeah.
We're going to say
height.
We're going to say this.height is equal to H.
Okay.
So now what happens is TypeScript defines a function in our program such that if we type new and the name of the function, a new person, pass in the argument we defined here, we will receive an object that has one property, or that has any number of properties, and all of those properties are the properties that were defined on the object called this. Said a lot there.
Now this is the object called this right here,
Yes.
and
It's the object we're creating.
the only property is height.
Yes.
So it's this and it's dot, and then this is the property.
right.
You know what I'm saying?
So if we
So like,
yeah.
Maybe I should get like, so it's like this. This is just like this. Oh, there's two. Oh, no. It's this dot property basically.
yeah.
This is like the generic version. This is the This is the Walmart version.
Right.
Okay. Yeah.
So
Cool.
the object we just created, it has the height property set equal to whatever we pass in the constructor. The constructor. So here, we created an object called Brian, set it equal to the result of this constructor function. So that means that now Brian is going to have a property called height, and height is going to be set equal to 7. So if we were to console that log Brian.height, it would be 7.
Okay. So you just through this, it kind of is defined automatically by putting it in the equation. So it's like you kind of defined. Now, what's the purpose of this? Because you don't put it in here.
Right. So here is the purpose of it. Let's say we want to create a new object called RJ. RJ is a type person.
That's me.
Yeah. Let's say we did a new person. And let's say you were 5'11". Well, now if we were to console that log RJ dot height, what value is that going to have?
71.
Right. Now, what value is Brian going to have?
70.
Exactly, still 70. So, this is it's a way to refer to the name of the object you're creating without actually knowing its name.
Yeah.
Because the name isn't defined until after the equal sign returns the value.
Yeah. Okay. Yeah. Class, person, constructor. Now, where does constructor? Yeah. This is all kind of general. Yeah, this is very like, this is like the general, there's no specific file names in here because like, this is applicable to all of the names that we would put in there, right?
Yes. Now, I just realized if we were to run this code, type it all out in TypeScript, it would throw an error.
Okay.
And the reason for that is we said that Brian and RJ both conform to the iPerson interface. The thing is, iPerson interface expects there's also a method called jump.
Okay.
And if you look, our class person, it doesn't implement the jump method.
Okay.
All it does is implement the constructor method.
Mm-hmm.
So we need to create a method called jump.
Mm-hmm. Okay.
And
Okay, so to put this, you have to put constructor above it. Like these are kind of together, or no?
oh, well, this is a function called constructor. Like this dot height, that's just the body of the constructor function.
Yeah. Okay.
Yeah.
Yeah.
So we could just say
Because you don't have a. Oh, I see. Height is just a. Okay, so up here in iPerson, the interface, height is a requirement.
yes,
Okay. Jump is a method.
yes, and it's also required.
Okay. Okay. Okay.
So here I just kind of messily wrote out a method. It doesn't functionally do anything. All it does is print out a message saying that I'm jumping.
Okay, I have to go back. Sorry. So if you have interface, an interface is kind of just like defining what's required for each thing.
Yes.
And so like if you want to mess around with person,
right,
you have to have all these things.
And now the reason why we have interfaces is so that you can actually
tidy.
partially, but the real reason is so that you can have multiple classes that implement the same interface.
Okay.
So let's say we were create. Let me take a picture of this because I actually did that for my other project.
Okay.
Oh, she got that one working. Wait, what?
No, but it's just a reflection.
Are we on that?
It's a reflection.
Oh my god.
It looks like it's legit on there, but
Wait,
it's not.
whoa, that's really trippy.
Yeah, I know.
What? Are you serious?
Yeah, you can't tell until you get into the room.
Oh my god, that is so weird. That's almost exact.
I know. It's
Holy
really crazy.
crap.
Yeah.
Okay.
Alright, so I'm going to erase this. And then hopefully what I'm going to draw next will show you the purpose of interfaces.
No, I think like interfaces are, you need a marker?
That one's kind of bad, but for me, I may be incorrect, but I'm just kind of explaining how I think I understand it.
But an interface is so that everything is, okay, no, you just said that we have interfaces so that you can use it for different classes. That's what you're talking about.
Alright, so here we're creating another class. You want to almost always define something called a constructor function, and that's where you set the values of the properties of this based on the arguments you pass in the constructor function. So again, I'm just going to say this the height equals h. One other thing you can do, which we could have done over there, is you can define any amount of properties you want. So we could just say any awesome person has a weight of how much do you weigh?
Probably 190.
Yeah, of 190. So we're gonna hard code that anybody's weight is 190 if they're an awesome person, even though that wasn't passed in as a constructor argument, and even though it's not part of the interface.
So this would be any awesome person.
Yes.
Okay, and this has to be something person. Right?
No. The name doesn't matter. We could call it a turtle. We could call it whatever you want.
Okay.
It just.
Well, how do you connect? How
We'll
do
get
you?
there, we'll get there.
Okay, all right.
Alright, and then we can have another method. We can have a method called jump. And this will do, I'm just going to write seed.log instead of console.log.
Yeah.
Something easy. I'm jumping really high.
I'm just pointing to this because it's.
Yeah. And then we could also define another method if we want. We can call it run. We could say c.log.
And what does that string mean? I'm jumping really high. Is that it's going to say that?
Yeah, it'll print
Okay.
that out in their console. It's not a program that means anything, just prints messages.
Yeah.
So I'm running. Alright, so we could say
Now console.log prints messages.
yeah, we've seen that before.
Yeah.
So we could do Andrew. Your brother's an awesome person today. I person is equal to new awesome person. So his interface still conforms to type I person, but the class is, let's say, how tall is he? Say hi is he? Let's say 5'11". I don't know, 5'11".
Yeah, like 5'10" and
Yeah.
3/4.
Yeah, exactly. Yeah, round up. So if we were to type Andrew dot jump, what would happen?
It would print out. Like I'm jumping.
It would print out
As
whatever was defined in the awesome person class.
Okay, because the Andrew's a new.
It's an
So
awesome person.
okay, because it subscribe or what? It follows the interface of this, but then equals. Okay, so is interface kind of above class?
Interface
Or-
defines the names of the properties and methods. It does not define the values or the behaviors of the methods.
Yeah.
The values
okay.
of the properties are the behaviors of the methods.
So the interface defines the name
Yeah.
of the properties. Is that correct?
Yes. In the methods.
And the methods. So is this a method?
No. So a method is anything that has parentheses.
So
And
this
I
is
say
a
at the bottom.
method.
Yeah.
And then this is just a property.
Yes.
Okay. And so the method and okay, so this is kind of like this is the type of equation we're going to be using, basically, or no? This is the type of method we're going to be using.
Yes.
Yeah.
It's saying that any object that conforms to the iPerson interface must have a method called jump. It must have a property called height.
Okay. Yeah.
But we aren't going to say how the jump behaves.
Yeah. And then when we go to class, it says awesome person. But where did you connect awesome person to iPerson?
We don't.
Okay.
We don't connect at all.
That's
All
cool.
we said was that Andrew would be a new awesome person, And when we run this code in TypeScript, there won't be an error because AwesomePerson has jump and it has a height property.
Yeah. And in Andrew is, what is this called? This interaction between Andrew and person.
He conforms to the iPerson error.
Yeah, okay, cool. And then, since he's an awesome person, let's see. Yeah, okay, new awesome person. What does this mean? Does this mean just that Andrew's a new awesome person?
Yeah, it means that this constructor function gets run. It creates an object called this, assigns these properties to this,
Okay.
and then assigns that this equal to Andrew.
Yeah, okay, so he runs, so this means that it runs this, right? Okay.
Yes.
So now when it runs this, constructor height for a number, and then this would be Andrew, right?
Yes.
In this case, so it'd be Andrew dot height equals, and then
71.
because, but why does Andrew equal 71?
Oh, because he passed in 71 here. Let's make it
Oh,
bigger.
okay, you passed that in. Yeah.
Let's say 73. His height would be 73 now.
Yeah, okay, so now Andrew's height equals 73, and then when you do Andrew dot jump, it would, okay, what has happens here? This means that we want to run jump under Andrew.
Under
Andrew's inputs or something?
Yeah, under the AwesomePerson class.
Yeah.
So
okay.
the JavaScript interpreter will look for the class called AwesomePerson.
Oh, and it'll say I'm jumping really high.
Yeah.
Yeah, okay. Okay, cool.
Right. Now, let's turn it up a notch. Are there things you aren't following yet? Or?
No, I'm good. I mean, I'll have to watch this again to remember it. But so
is there enough resolution on that? Can I see?
Does it zoom? I think it can. Wow. I'll bring it closer.
Put it on that shade, bring it closer.
Yeah. Dude, that is so tricky.
I know it is. Plug D3 in there.
Yeah, plug D3. Someone said, what happened? Oh, we'll talk about it later. No.
All right.
Recording stopped. Hold on.
So if we want another example to help you generalize the concept of interfaces into your brain, we could have the difference between interfaces and classes. We could have an interface called iCar.
Okay, I think there's some movie recording. Hold on. Oh, maybe it stopped. Oh, it is. Oh, okay. Hi. Okay. Oh, yeah, that's better. I have more memory cards in my car, too. Alright, you keep going. I just have to write that down. Okay. To do. Okay.
Alright. I don't know if you're supposed to draw the brackets here. I'm not sure. Don't worry about it. Alright, so let's say we had an interface called iCar.
Mhm.
iCar could have two properties and one method.
Mhm.
So let's make it class. Yeah,
Two properties and one method.
Yeah, so one property is called speed, another one's called number doors, and one is called accelerate.
Yeah.
So we can define a class called Camry. Toyota Camry. Constructor. S. N. So we're going to say this dot speed is equal to S. And actually, our constructor is only going to accept one argument. It's going to accept a parameter called N. That N is going to stand for number of doors. So we can say this dot num doors is equal to N. And then we're going to say this dot speed is equal to 0.
Mm-hmm.
And then we're going to find a function called accelerate. And what it's going to do is say that this dot speed is equal to this. This is a new concept.
Mm-hmm.
it's equal to the old value of this dot speed plus 5. So
Okay.
if we say const,
But won't that just like keep feeding itself and just go?
no, it only gets run once.
Okay.
Yeah. So if speed was 0, this dot speed gets set equal to 5.
Mm-hmm.
It understands how to read it. So you say const John's car is equal to new Camry. Now we say John's car dot speed. What will get printed out?
9.
If we did console.log.
9.
9. So 4 is just the number of doors.
Oh. Okay, wait. So const John is, what is const represent?
Just the stands for an object.
It's like new object
Yeah.
of John.
Yeah.
And car. Now.
John's car. That's just the name of the object.
Now, if you, even though you wrote John's car, it still isn't really connected to anything. It's just named John's car, or does
Well,
it?
it gets connected to.
And then equals, yeah, it's a
So-
new Camry. So for this is an object, and this object runs new Camry.
Yes. Yeah.
Okay. And 4 is, okay, because the number of doors is, these two aren't connected yet, are they?
Correct. They are not.
Okay, so new Camry, so it runs Camry and it has a constructor, so wait, is this H or N?
That's N.
That's okay.
Yeah.
So N is, now when it says constructor, does that just mean that when you type Camry and then the parentheses, it puts this is the input basically?
Yes.
Like this and this.
Yes. Exactly.
And then you have wait, what is this? Console log? Okay.
Yeah.
So you have console log, John's car, which would mean like print the speed out.
Yeah.
And so it would be 0.
Exactly.
Yeah, okay.
Now, let's say we did John's car dot accelerate, and then immediately after Ruth, we again do console.log.
Oh, that's cool.
John's car dot speed.
Yeah.
What gets printed out?
5.
Exactly.
Nice.
You can keep doing that. It'll be 10. It'll be 15, 20. so
Yeah.
on.
Okay, so
And
that
actually,
would be like if you had a button that executed that, it would just go faster,
Right.
faster.
and what I should have done is said, I don't have to do this, but I could have said John's car must conform to the iCar interface.
Yeah.
And then that way TypeScript would have thrown an error if the class right here, the Camry class, let's say it didn't have an accelerate method,
Mm-hmm.
TypeScript would have thrown an error.
Yeah. Very
Nice.
cool.
So
And
this,
so, because you want to subscribe, okay, wait, where? Here, const, John's car. Okay, because this is, wait, what did we have here before? We just had const John's car?
yeah, it didn't make it conform to any interface.
Okay, so you could have const John's car just equal new
Yeah.
Camry.
And what changed the behavior?
Yeah, but
It'll
now
just,
you add this, and then so it conforms to the interface.
right,
But
meaning,
that,
meaning if this class did not have
Yeah.
2 properties and 1 method, those 2 properties, 1 method, TypeScript would throw an error.
yeah. Okay, because you want John's car to follow these properties, and then, right?
Yeah.
Okay.
So let's
Very
do
cool.
let's do another
Yeah.
example.
Yeah.
And we'll say class Lamborghini. It's gonna have a constructor. It's gonna have num doors. So we're gonna say this dot num doors. Sloppy equals num. This dot speed equals 0. Define accelerate method. It's going to say this dot speed is equal to this dot speed plus 20. So now we can say const RJ's car, make it conform conform to the iCar interface is equal to new Lamborghini. I'm just writing Lam. Passing 2 doors. All Lamborghinis have 2 doors, so I don't even know why you pass. Yeah. So let's make this a no. Make this a no constructor from a no argument constructor. This number is equal to 2. We just say equals new Lamborghini. And if you were to do, you know, RJ's car dot accelerate, and then console.log RJ's car, so that's speed of V20.
Cool. Const. This is const, right?
Yeah.
Const RJ's car. So like you kind of making it, and then it subscribes to that equals new Lambo. Yeah, and it needs to have. What does it? Yes, it subscribes to that, so it needs to have the speed. But you don't have speed here, so wouldn't it throw an error?
We do speed on Lamborghini.
Okay. So once I'm equal to new Lambo, what is this Lamborghini? Yeah. I automatically get that. This would kind of like be there, and then so you can just here you type in to run the accelerate function,
right?
And then you type in console log to kind of check in to see what the speed is, right? Okay.
So I did gloss over some details. We can go over those later.
No, it's okay.
Just keep your brain flexible for when we add those details later.
Yeah. Well, you just learn it bit by bit. I mean, you can't learn how to split atoms until you learn what atoms are.
So the benefit is that we might have some function, some method, right? It has a parameter called car. So let's say we have a function called ride-in. Or drive.
Called what?
Let's say we have a function called drive.
Drive. Okay.
And it just takes one parameter called car. We can make that car inside the function. Let's say this is not part of any class, it's some standalone function. The way you do that in JavaScript is by typing function. You've probably not seen that yet. You can say car equals iCar, and what we could do is say car.accelerate, and that would start the car up, or maybe make it go faster. Maybe you jumped in the car, and just make it go faster. This will call, well, whether car, so we know the car is of type iCar. We don't know if the class was a Lamborghini. We don't know if it was a Camry or other things, but our code doesn't care about that. If it turns out the car was created through the Lamborghini class constructor, or whether car was created through the Camry class constructor, car.accelerate will call the correct accelerate method. So if this car just happened to be a Lamborghini, car.speed will now be 20 higher. If this car that was passed in as a parameter happened to be Camry, speed will only go 5 faster.
This is just a generic for all cars.
Right.
How would you define, like, how do we know that a Lambo is a car and then a Camry is a car? Would you have to, would it be this, or would you have to do some other definition?
Right. So we actually don't know. Well, okay, the way TypeScript works is it does something called duck typing, meaning it just looks to see if Camry has an accelerate method and it has two properties called num doors and speed. So upon runtime or compilation time or whatever, it just kind of checks to see when running this line if Camry does have the same number of properties and stuff as iCar, same names.
Okay.
If it doesn't, it'll throw an error. But if you want to make sure that the class itself conforms to the iCar interface, you can actually write something called class Camry implements iCar. And then rather getting an error thrown here, when you try to assign a Camry to an object of type iCar, rather than getting error, let's say if you did not have an accelerate method, let's say you had an accelerack method. Normally you get the error thrown there. But if the class conforms to the interface here, we'll get a red underline here saying Camry does not conform to the class.
Yeah. Okay.
If we remove this, we would get no red underline here, and rather we would get the red underline here. Because John's car is of type iCar. iCar is expecting accelerate, but we looked at Camry. Camry does not have an accelerate method. It only has accelerate at.
Now, do you just want to put implement in like both of them then? Or no?
Yeah, we usually do add implement here. I just left it off for now because it's just an extra detail. But looks
Yeah.
like you picked it up.
Yeah. Cool, man. That's dope. Yeah.
So we went over this. I'm not sure why, but it's like it's
We came from here.
yes. Okay, yeah. So what I was getting at is we have a class called subscribable core,
Yes.
and what I wanted to explain to you was the concept of this, like the this.
Yeah. Right here.
So
Here,
let's
what's
say,
this?
yeah, you finally erasing everything now.
Well,
Or
I
somewhere.
want to go back to where we were.
Yeah.
So just that.
Yeah, you just download some new dependencies. Let's hope that if we keep using the things you just downloaded,
Uh-huh.
then according to Forgetting Curve, we won't have to re-download them a few days from now.
Yeah.
Yeah.
Uh-huh.
So it's good that we do this in the morning and the night so you don't forget it.
Because what? Better to learn in the morning?
Well, no, what I'm just saying is let's say 3 days from now, you have to re-understand the concept of this.
Uh-huh.
Well, I might have to walk you through the whole tutorial.
Yeah.
But if we were to use the concept of this 5 minutes later like we are now, let's say you had already forgotten 10% of this in your brain. Well, now we're about to use it again. I'll go back up to 200% and then start to think slower.
Yeah.
Yeah.
Let's
Let's go. So we have a class called subscribable core.
Yes. Yes.
Inside of that class, I believe we have a function called onUpdate. I'm like
Okay.
99% sure that's what it's called. We also have a property called callbacks. And that callbacks is something called an array.
So here, wait. Let's do it like
You
this
wanna
is
create
the.
the interface
I
for it?
just want to
Yeah.
like just mimic that.
Awesome.
Just 'cause,
Awesome. This is sick.
right here, like
Yeah.
subscribe.
Alright, so yeah, you create what do you think the constructor would look like for subscribable core.
So this is a constructor.
Yeah,
or what?
this is constructor.
Yeah. Okay. What is it? This is just a class.
That's class, yeah.
So the subscribable core is the class,
Yes.
and then you got.
You gotta have a bracket, open bracket.
Okay.
First thing to do,
Is the constructor.
it doesn't have to be first, but it's just
But so what is the constructor is? Wait on. What is that? What was that again?
that was the parameter name. So in our case,
Was it number?
it was H, which was of type number.
Yeah. Okay.
For us,
It's gonna be callback.
yeah, we actually don't need any parameters in our constructor function.
Oh, okay.
So you
So what?
just have a blank
That's fine.
parentheses.
That's
Yeah.
fine.
And
I'm
then
just
you
doing it
need-
because I
you need
know
a
this.
bracket. You need an open bracket after the
Oh, okay.
after parentheses. Yeah.
Okay. And then you got.
So we're gonna say this dot callbacks.
Yeah.
Is equal to an empty array. And the way you define,
And
What
then
this
an array is
concept of
just a
array
set of
is.
numbers.
yeah, you write this, 2 square brackets.
Okay. Like this.
An array
Okay.
actually, it isn't just a set of numbers, it's a set of any type. It could be a set of objects,
Set of-
it could be a set
okay.
of cars,
Yeah. Set.
it could be a set of numbers. Yeah. But
This was just like the 501 and the 502 and the 503.
Exactly.
Okay.
but you want to write comments right there. I mean,
Yeah. I know.
Yeah.
I'll just okay.
then you can close the constructor function.
Okay, so this is the constructor.
Yeah. And normally you would have indented the body of the constructor. You would have indented the inside, but that's no big deal.
Like, what do you mean? This part right here?
Like, see how I have bracket
Yeah.
and then-
Oh, well, no, I'll do that. Because I'm just like mimicking. Shit, what did I just write? Callbacks? Right?
Yeah. Well, this is really interesting watching someone learn things for the first time because there are details that your brain just doesn't pick up on yet.
Really?
Like, just like indenting. Like, it's not that you're stupid.
Yeah.
It's that's just the way the human brain works. They don't pick up on all the details at first.
Yeah. Well, I mean, I kind of, yeah.
I see it.
It's not like I don't have it locked in yet.
Right.
Because like if
And
I
for
was
me,
on the
it's so
computer and I
automatic.
saw it, I would be like, I was just following.
Right.
But to you, it's second nature. To
It
me,
is.
it's just I'm mimicking.
Yeah.
Okay, and then is there anything else?
You gotta close a constructor.
So wait, is this a function of this?
Yeah, it's
The
a
class?
function inside of the survival core class. And remember, when we say a function inside of a class, we call it a method.
Yes, yes. Okay, so this method would be like I probably put
Yeah,
that. in
first we
here
need to close a constructor method.
too. Okay.
But
Is it just yeah.
it's a closed bracket, yeah.
Yeah.
Alright, so now we're going to create a method called onUpdate. So right, onUpdate
Yeah, yeah,
here.
yeah. Lowercase n, right?
And remember the example I gave to you. OnUpdate is like it edits the list of callbacks, the list of tasks.
Yeah,
It adds another task to do upon
Yeah,
upon
it
receiving the update.
like changes it a little bit, or it adds something.
Yeah,
It
but
adds
the way
something
we've
to
defined it is it just simply adds another callback function into the callback list.
Mm-hmm.
So this you want one argument.
Now,
And you-
when I'm writing an argument, I do regular parentheses.
Exactly. And let's name the parameter in this argument. Let's name it func, func, standing for function.
Now, parameter is the first thing that you write.
Parameter is just the name of
Show me a
something inside
parameter
parentheses.
that do we have a parameter written around here? Or no.
We actually, but this is a parameter. N is a parameter.
Yeah,
so it's
okay.
a function.
Yeah, yeah,
But
okay.
if we have, let's say.
Oh wait, you said
define-
the parameter was, like f, the function f, x is a parameter.
Exactly.
Yeah.
So we're gonna learn another
It's a
definition too.
variable.
X squared plus 3y. So let's say we have a function called f.
Yeah.
We have two parameters called x and y.
Yeah.
But you might have heard me say things called arguments before, right?
Yeah.
It's a subtle difference. So when we call f, like let's say we say
Yeah. I'm good with the math kind of analogies.
yeah, let's say my favorite number is whatever this function of 2 and 7 is.
Okay.
When we're passing in a value into the function, before it gets inside of the function, these are called arguments.
Okay.
And then the genericized version
Yeah.
inside of the definition of the
Yeah.
function are called parameters.
So arguments, I'm just going, this isn't right, but arguments are numbers and parameters are variables.
Yeah, that's one thing.
But
Well,
obviously,
arguments are two numbers as parameters are two variables.
yes, that's more correct.
Yeah, it's analogy.
Because this could be a letter, it could be right. Yeah. Cool. Okay, so wait, let me write that down so I remember. It's like an argument is to number as parameter.
I gotta call my up on a Craigslist call and see.
That's cool.
Nope, it is spam or something. Mine busy.
Parameter is to variable. Now, is that right? Argument, or should it be argument is to parameter as number is to variable? Does it matter?
Analogous. It's,
Does it matter?
however you want to draw your analogy, either way is logically consistent.
Yeah. That's what I was trying to do yesterday. I was trying to describe the logic of my situation to my dad, and he was just getting pissed.
Yeah.
Anyways. Okay, so I'm good. So, wait, here, no, give that back. Okay, so here, I need first my parameter or my argument. Prime parameter.
Well,
right?
here you're defining the function, so it's called a
Yes.
parameter. You're not calling
Yes.
the function.
Yes.
And actually, in this case, they're called methods, not functions. I shouldn't
Yes,
call them.
method.
Yeah.
Method. So for the method, is it G? Would it be
Well,
G?
in this case, it's a.
Or that, this is
This
an
was
argument.
an argument.
Yeah, that's the argument.
Well, okay, this was bad syntax. I was mixing
Sorry.
stuff together. I was just writing
yeah.
some But yeah, right. Yeah. So I would give your parameter name func, like func.
Okay.
Short for function.
Yeah, okay, because these are going to be function probably, right?
And then we aren't gonna type a function. That'll be a lesson for another day.
Okay.
Or okay, let's assume there was some interface or some type called function with a capital F. We would
Wait,
type
say that
this
again, sorry.
together.
So let's say there's some interface, okay,
That
that,
properly says that the following object is a function,
So
then we
it
would call that interface function with a capital F.
Okay.
So we can say that func is of type function.
Okay.
And all functions are defined to have the behavior such that, alright, so let's say f, we say const f. This isn't exactly how TypeScript works, but let's say we have const f, we typed it to be of type function. We could say, I don't know, well, whatever, somehow we set it equal to something. Function with capital F, that type means that we can later use parentheses on the object and
Nice.
TypeScript won't error on us.
Yeah.
So this is actually saying that we can invoke. Invoke is the term, that's what we say when you have parentheses on an object. So when you call a function, the proper name is invoke. I don't know why you say that, but we just Alright.
Squiggly bracket?
Yeah, there you go. Alright, so on update, what we want to do, the on update function, we want to add the parameter into our callbacks list.
Okay, so I'll just like write. Now, what is write func here?
Yeah, but I mean, we're defining code. We can't just go like that. The proper way to add something into this is called an array. The proper way to do that is by writing this dot callbacks
Okay.
dot push, and then
Push
your
Push.
argument.
push this into callbacks.
Yeah. So now,
So this.
if this code were to get executed, the state of this dot callbacks would now be func. It'll have one element of the list.
Yeah. Only for on update.
Yes,
Because
after running on update.
on update is a part of the class subscribable card. Right.
Yes.
Cool.
Well, no, on update. Well, on update is it's a method. Inside
Yes,
the class
you're right.
subscribable card.
You're right.
All right, so
Yeah.
this is good. So you close out this function.
Which way? Okay, so this would be like
Open.
open, so it has to point
Yeah.
the other way. So
There you go. Nice.
yeah.
All right.
That's kind of big.
Yeah.
Whatever.
So now let's define the receive update method.
Okay.
So yeah, write out receive update.
Now receive update. What's the point of that? Okay, right here.
Yeah.
Oh, because so on update was gonna change. So these are all like little functions,
Yes.
basically.
Change the
And-
list of tasks you have to do upon receiving that letter in your desk.
Yeah, and so on update changes these a little bit,
And then update, what it's going to do.
and then so wait, this is receive update.
Yeah. Update is going to call each of those functions one at a time.
Yeah. Okay. With like receive update is going to, is this a what is this? Is this a method? Is this a
That's a parameter update object.
okay?
So receive update has one parameter, and it's
Yeah.
something called an update. And that update, it contains certain properties and stuff.
Yeah. Okay. So I should do this update object. Right.
Yeah.
OBJ.
And we're going to say that that conforms to the I update interface.
Mm-hmm.
You don't have to know what
Yeah.
that interface
Yeah.
holds.
You just keep going and say.
Yeah. Alright, so let's close that.
Then should I open up one?
Alright. Are you familiar with the concept of for loops?
I've heard it before. I don't know what it is.
Alright. A lot today. Alright, so
Well,
we're
am
gonna
I
say-
retaining a lot? That's what matters.
Yeah. As long as is this still recording?
Yeah.
You might have to do some review on your own.
No, yeah, I will.
Alright. So
I should dedicate like when's the optimal time? So like would it be like directly after, or should I review in like maybe an hour after we do it? You know what I'm saying?
it
Or
is
to the
more
forgetting
optimal to wait.
I wonder how long. Do you know?
Well, that's the purpose of branches for us to find out.
Yeah, that's true.
No, I've seen some studies where like,
We
if
could
you're to
just
study
test and
4
learn.
hours, if you study something 4 times in a row, 2 weeks later, you would remember almost nothing. Whereas if you study something once now, once an hour later, once a day later, once
Yeah.
a week later, end of the week, you would naturally know a lot more.
Yeah.
So yeah, it's more efficient over the long term to space out the review.
Yeah. Okay. See, my I'm trying to figure out like how many hours after we like do these the
Right.
morning.
Well, it's really going to depend on when you're using these skills.
Yeah.
Because if you need to be using these skills 10 minutes from now,
Yeah.
you don't want to forget them.
Yeah.
If you don't need them really for your test 2 weeks from now, it'll be okay if you forgot them for a few hours.
Yeah.
Alright, so in JavaScript, we have 2 types of variables. We have const variables,
Mhm.
and we have let variables. Const variables are variables that you can only use the equal sign on them once.
Mm-hmm.
So you can say like const RJ is equal to new person, right?
Mm-hmm.
And then
Does const stand for constructor?
stands for constant.
Okay.
It's unfortunate naming convention.
That's okay.
So you can call things on RJ. You could say RJ.jump, right? You could say RJ.height.
Mm-hmm.
You can print that out on the console.log statement.
Mm-hmm.
And you can even change RJ.height manually. You could say RJ.height is equal to 75. You just grew a few inches.
Mm-hmm.
But you can't reassign RJ. You can't say RJ equals another new person.
Yeah.
The reason for that is RJ is a constant.
Yeah. That'll throw an error.
Yeah, it'll throw an error. So if you want to use the equal sign on a variable a second time, you have to use something called let. So we could say let.
So you can if you use let.
Yeah. So let's say let time equal.
Oh, I see.
What's the time right now?
I don't know.
It's 11:29.
Okay.
So I just updated every hour. Let's say time equals 11. We could have some program that every hour it updates time to new value. So this time equals 12,
Mm-hmm.
time equals 13. That won't throw an error.
Mm-hmm.
And then if you remember this kind of logic over here, we could whatever program is updating the variable of time, it could say time is equal to time plus 1, right?
Mm-hmm.
And there's actually a shortcut syntax where instead of saying time equals time plus 1, this might be confusing. You can literally just write time plus plus.
Mm-hmm. With that, we just add 1.
It literally just adds 1. So the next time you use the time value, it's now, well, okay, let's say time is 13, now here time is 14, now time is 15.
Yeah. And how would you do? What if I did like time plus 2 plus? Would that mean it would add 2? No.
It would throw an error.
Okay.
It only works for plus 1.
Yeah. Okay. That's fine.
Similarly, I don't know, you can't travel back in time, but if we had some program that let us do it, we could do time equals time minus 1,
Mhm.
right? And analogously, you could say time minus minus, and that
Mhm.
also decreases the value. Anyway, what I'm getting at
Mhm.
is that you can only use the equal sign on variables declared as let. So here, we're going to create something called a for loop. And we're going to create something called an index.
Mhm.
We're going to name that index I. We're going to set it equal to 0.
What is the for loop?
What
This is the whole thing we're about to do. Is
Yeah,
okay.
yeah,
Okay. So let I equals 0. Is that I?
Yeah, that's I. And we're also going to create something called a condition.
So I is less than.
I is less than, I don't understand this yet, this dot callbacks dot length.
Okay.
And then we're going to say, this is a semicolon. And we're going to say that's a semicolon as well.
Yeah.
And say I plus plus. And again, I don't
Plus
expect you to
1.
understand what any of this means.
That's okay. I is greater than the callback line.
So,
And I is also.
well, these things aren't all true at once. So,
Okay.
we're defining 3 commands right here. All these
3
commands.
parameters.
Yeah.
Okay.
So this isn't a function. This is a new syntax.
Is
This
that FOR? For.
So this is something called the header of a for loop. I don't
Yes.
even know what it's called header. That's what I call it.
Yeah. For loop.
It defines 3 different things.
Yeah.
Each of these 3 different things are used for different reasons and used at different times.
Mm-hmm.
So the first thing, that's called the assignment statement. That creates a new variable called I.
Mm-hmm.
That sets equal to 0. And it tells us we can change the value of I.
Okay.
Because it's a let. So what we're going to do
Mm-hmm.
is after this assignment statement gets run, we enter the body of the for loop. body of a for loop, it's a series of lines of code that gets executed, and then later we modify stuff up here and we enter the body of the for loop again, and we modify some stuff up here, we enter the body of the loop again, and so on and so on.
So a for loop would be this does it first, puts it in the body, and then does this, puts it in the body, puts this,
Yeah, exactly.
and that's why it's called a for loop.
Yeah.
Okay, cool.
And it keeps doing it as long as this condition is true. So let's jump in the body though. Okay. So what we're gonna do is we are going to access. Alright, remember how arrays in JavaScript and TypeScript as well are zero based? So this is the 0th position of the array, this is the 1st position,
Okay.
so on and so on. Actually, this is interesting. The way I wrote the example was that we added A first, then B, and then C, and then D. Do you mind if I draw the array backwards? So this is index 0, this is 1, this is 2.
Yeah, okay.
Alright. That'll generalize your brain more too, so you get locked in to a specific example.
Yeah.
So we're going to say const function to invoke. Invoke is just a fancy word for run. Call. Const function to invoke is going to equal this dot callbacks bracket I. So what this means is we just retrieved the 0th function. That function was called A, and we set that function equal to the variable called function to invoke.
So it comes from here. Because this is the subscribable core? Or this is
This is the list of callbacks. This is
Okay, cool.
Yeah. After we called on
Oh,
seven times. So
now each of these would be listed in here though, like A, comma B, comma C, comma D.
Exactly.
Yeah, okay, cool.
So remember, the way you call a function, the way you invoke a function, is by writing the parentheses. So let's say this function, it's defined to have the following code, it has some stuff, and one of them is console.log. Hello. Yeah. Hello, right?
Yeah.
When we run, so we run A, console.log will print out hello.
Yeah.
Right. So we now have function to invoke. We don't write A parentheses because we don't have access to the name A. All we know is that we have access to an array of callbacks called callbacks.
Yeah.
And we
So
can
the more generalized code, you want to be able to do it for all of them.
Right, yeah, we can access the position of them, and the way we're just temporarily calling that function to invoke. So we're going to actually invoke that function. So what am I going to write here?
Well, okay, wait.
This is so abstract.
Function to invoke can't be equal to anything else though, right?
Yeah. Okay, these are two different lines.
Oh, okay.
This is
Now, okay, so you're setting function to invoke equal to this.
Yes.
Okay, and then you're asking me function to what is this equal?
Well, I'm not saying what it equals. I'm saying what are we going to do with this line? We're not going to set it equal to anything. We're actually going to invoke the function. So we didn't set anything equal to anything. All we did was execute whatever instructions are present inside of the function A.
Yeah.
And the instructions we defined were console.log hello.
Function to invoke. Now, is this a general term right now, or is this the exact code that we would put in?
That's the exact code we would write.
Okay. Function to invoke. Now, is this just the function to invoke within this little thing right here? Because like, what if you were doing some other thing and you wrote constant function to invoke? You could write it there too, right? Or no?
You can write any code anywhere, but not all variables are accessible anywhere.
Yeah. Okay.
So this
okay.
dot callbacks is only available inside of the subscribable core class.
Yeah. Okay. So function to invoke. So we want to invoke each one of these every
So
time.
We only invoke function A right now, though.
Yeah, I know. Yeah. So it's like you want it to run A, and then you probably want it to run A three, four loops or whatever, right?
Well, we're only gonna run each one once.
Okay.
You'll all right. So let's continue. I think you'll understand something.
Okay.
So what happens?
I wanted to get this right.
Yeah. What happens after you run the body of the for loop is the JavaScript runner. It's called an interpreter. It goes to the top of the for loop again, and now it looks at the second statement on your head, and it looks to see if this condition is true. So, if we were to evaluate this statement, I in our current case is 0. This dot callbacks dot length, that's the term for the number of elements in the callbacks array. So how many elements do we have in here?
So, well, 7.
7.
Right.
So is 0 less than 7?
Yeah.
Correct. So this evaluates to something called true.
Okay.
You have statements evaluate to either true or false, right?
Yeah.
So now this statement gets evaluated, and if this statement passes as true, we go into the third statement.
Yeah.
And that, what does I plus plus do?
Oh, you just add 1 and then you just keep going.
Exactly.
Oh, very cool.
So now I is equal to 1.
Yeah.
We go here. Function to invoke is 1.
Okay.
Yeah. What's function to invoke?
It would be okay. What is the function to invoke? Like, which function do we want to run, basically?
Yeah. Which function gets run?
Like, the next one would be B, right?
Exactly. It's the 1th position of the callbacks array. We invoke it, and whenever B is defined.
Oh, because I is
I is
because
not
you
1.
set I is now equal to 1. Yes.
Yeah.
Okay.
So let's say we define B to have the following behavior,
Yeah.
some stuff, some other stuff, and then console.log by
Yeah.
that would get printed out.
Yeah. And then okay, so function to invoke. This would just be one of these guys,
Yes.
or would that just be?
Well,
Because I is equal to
It'll be-
0 and then 1. So function to invoke would just be the callbacks list. Wait.
it would be the specific element of the callbacks list that we accessed
Yes.
by using the index we defined.
Yeah. Yeah.
So we access the 1th position in the callbacks list, which is B.
Okay.
And now,
Yeah.
essentially, this code gets here, the JavaScript interpreter interpreted as that. But we saw it as function to invoke.
And what is this? Is there anything that goes in there?
No, that just means call the function. So we have the function name, and the way we run the function, the way we invoke it, is by writing 2 parentheses.
Okay. Because I thought we were trying to put something in there.
No, yeah. So you were thinking we were like defining it?
Yeah.
Nah. So we aren't
Cool.
defining the function. We're
Very
invoking
cool.
it. So yeah, the function we did not define it here. It was defined wherever A was defined,
Yeah.
and then we passed in the value of A
Yeah.
into on update. On update added the callbacks list, and then we access that function from the callbacks list here.
Okay, when you said, what do we put next or something, and you
Yeah.
said it's very abstract, was it just that it would go here, and then it would be like, is this greater than, or is this less than 7? It'd be like, good, and then we would add 1, and then go like that. What did you mean by this was really abstract?
I meant abstract as in the sense that
Like,
we had never created an example of the function A.
yeah.
And then we're reading the function temporarily into something called function to invoke and then calling it. So there's like 2
Yeah.
levels of indirection.
Yeah. And what was the answer? Like, I forget what you asked.
Answer is that we write the parentheses
Okay.
to call the function.
Because I thought you were like looking for to put something in.
No.
Cool. That's very
Alright,
cool.
so now, after that, goes up to the second command again. Check, is this command true? Well, let's say is 1 less than 7?
Yeah.
Yeah,
And then
so
once
it
you
does.
hit 6, and then once you hit 6, it would go +1, and then it would be
Right.
7, and it would stop.
Exactly, yeah. So after we invoke G, we go here, be 7 less than 7, no, it's false. We don't run the third command. Now we go to whatever is after the for loop, and we aren't going to have anything after the for loop. We're just going to end the function.
Okay. Cool.
Alright,
Yeah.
so what we could do is, do you mind if I
No, you can
erase
erase
this
that.
up?
Yeah. I mean, we have a video of it.
Yeah.
Now, what is this? What part does this have to do with branches?
We have a class called Subtractable Core,
Okay.
and it's used all over the place.
Mhm. And this is basically a subscribable. Okay. Did you name it subscribable core, or is that just kind of the general name, and that's kind of what this whole thing is?
I named it Subscribable Core
Okay.
because we have another class called Subscribable, which
Yeah.
uses Subscribable Core,
Yeah. Okay.
and then tons of other classes use that Subscribable class.
Yeah.
So it's like
Okay.
the foundation of the foundation.
And then so you just have a bunch of things that like, so say you have subscribable core,
Yeah.
you have like all these things that it has to do, and you can basically take other. So there's classes that subscribe to this. What you like? From my understanding, there's I don't know what there's things that you basically just hook into this, and
Right.
it just like churns out shit.
Yes.
And it's just basically like you set up this subscribable core to do a certain thing. It's like a machine you built,
Right.
and then
Exactly.
these little things spit stuff into the machine and get out stuff.
Exactly.
Yeah.
Yeah. And
Cool.
some of these names and variable names might not be accurate. I'm trying to do this from memory, so I don't
Yeah.
really know if some of the stuff's
But the
incorrect.
concept I understand.
Right.
Yeah. I'm gonna probably like review that.
Yeah.
That's
So
dope,
if
though.
we were to, let's say we had a subscribable core. Let's go back to the office worker analogy.
Okay.
So we have
Yeah.
we have a worker.
Here, do we need a name? Are we good with this? Should we leave it or erase it?
We can leave that there.
Okay.
So we have a worker. He has a list of tasks that he completes,
Mhm.
right? And those tasks get triggered every time he gets a new message, every time he gets a new update put on his desk, right?
Yeah.
So we could say worker is equal to, and that this is, notice how sometimes I write things on 2 lines instead of 1.
Yeah. That's okay.
JavaScript's fine if you do that.
Yeah. Okay.
Is equal to new subscribable core.
Things don't really break until you put parentheses or brackets or anything like that. You know what I'm saying?
Yeah.
It's always
There are a couple cases where
Oh.
if you put a space, it will mess up.
Yeah, okay.
But I'll warn you about those. Alright, equals new subscribable core. Again, the constructor takes no parameter, so this is fine. And let's say somewhere else we define a function. Alright, so we're gonna learn 2 things. We're gonna learn we'll do 2 things. So let's define a function called say hi. Notice how this function is not attached to a class. It's like a free floating function. It just exists.
Mhm.
You can do console.log. I'm just gonna write clog at this point.
Yeah.
Looks like dog.
I understand what it means.
Yeah. Hi, right?
Mhm.
What we're gonna do is we're gonna add a task to the worker's work queue or his callback list.
Yeah.
So we can say worker dot on update. Anytime he receives a new message on his desk, the first task he does is say hi.
Mhm.
So I'm the boss. I put in paper on his desk. He says say hi. So let's do worker dot receive update. Let's define an update object. So const first. You can't start a variable with a number. It has to always be a letter.
Mhm.
So let's say const message. So we put a message on his desk. This message has to conform to the iUpdate interface, or else we'll get an error.
Mhm.
So we're gonna say iUpdate is equal to has stuff we don't know how it's defined.
Mhm.
So we're gonna say worker dot receive update message. So what will happen?
Where's receive update again?
Right here. This is receive update.
Now it's not the same thing here, is it?
It's the exact same thing.
Okay.
Except in this case, the parameter name is message. Sorry, the argument name is message.
Mhm.
But in here, the parameter name is update object.
Okay.
So in our case,
Okay.
argument is totally not a number. It's an object.
Okay. Okay.
And parameter is also an object.
Oh,
it just names
this
something
is an
different.
update object that subscribes to iUpdate,
Update object does not subscribe to iUpdate.
or what is it? It follows the.
It's just some message that has some properties that are listed out in the iUpdate interface.
Okay. Yeah. Okay. So update object follows the properties of iUpdate.
Yeah.
And
So we
so
could
does
have-
message.
Yes.
Yeah. Okay.
So we could write out some things in here. Like let's say we have
Yeah. Okay. Okay. So wait. What's the question again here? What will happen?
yes.
So the where does it say hi? Okay. Now, message equals all that crap. Is message a okay? Wait, no. This is a parameter at the moment. This is the argument.
Yep.
Okay, but they're both functions.
They're not functions.
Are they both methods?
They're just objects
Okay.
with some amount of properties in them.
Yeah. Okay.
They're getting passed into a function, passed into a method
Mhm.
called receive update.
Mm-hmm. And okay, so receive update has what is this?
A for loop.
A for loop. So this would run the for loop for message or no?
It does not run a for loop for message. Well, what it does is it runs the source line of code. So we set a variable equal to I equal to 0. We
Yeah.
then look at the
Hey, what's up, dude? What's up?
We're in flow mode, so we're concentrating. All right, so it looks at the this.callbacks array.
Yeah.
Right now, the this.callbacks array has one element, right?
Uh-huh.
What is that element?
This callbacks has one element, and it has just an array of functions. An array which is just a list of functions.
Yes, but upon creating new
For-
subscribable core, that array is what?
Just is what that?
It's empty. It's an empty.
Yeah. Okay. Okay.
And then we called worker.onUpdate.
Yeah.
And what did that do?
It put go. What did it do? Just tell me.
Put func
Yeah.
into callbacks, into this callbacks, right?
Okay.
In our case, func is say hi.
Okay.
So it puts say hi into the list of it puts say hi into this callbacks.
Okay.
So the value of this callbacks inside of receive update on this line of code is say hi.
Mm-hmm.
So this is literally a list with one element at the 0 position.
Mm-hmm.
So now we go here. Upon worker.receive update,
Mm-hmm.
this line of code gets executed.
Mhm.
We set I equals 0. We
Mhm.
set function to invoke equal to this.callbacks at the 0th position.
Mm-hmm.
So function to invite is now set equal to
Well,
say hi.
yeah. Okay. Yeah. No, I get that. Yeah.
And then now we invoke this function.
Mm-hmm.
So
And it says hi.
right, so we invoke say hi. So essentially, this gets translated into this line of code.
Yeah. Okay. Wait. Say hi, and then C. What's C?
Oh, this is console.
Oh, those are brackets. This is brackets.
Those are parentheses.
Yeah. Parentheses.
That's how
And
you
it just says
invoke-
run the
that's how you invoke
function.
Yeah.
Yeah, and then when you
Which
run the function, it just says C-log, which
Yeah.
means
It
print, and it
executes
just
lots
says
of
hi.
functions. Yeah.
Yeah. Good shit. Okay. But then here, and then it would stop
Yes,
because it's
one
not greater than.
or wait, yeah.
Because I is not greater than. Okay, so at this moment in time, I is equal to 0, and this callbacks.length right now is
One.
1.
I actually told you something wrong. The third
Okay.
statement gets executed before the second.
Oh, really?
So at the end of the loop, how does that work? Does it?
Well, let's just
Yeah,
think about it
yeah,
logically.
yeah. It has to be, or else type 0 would throw an error.
Yeah.
I was 0, right?
Mhm.
And then let's suppose that this got run after that, right? Let's suppose 0 is less than 1, right? So this is true. So what we're saying is that now this line of code gets executed. So now I equals 1, right?
Mhm.
Alright, I equals 1. So now we run this line of code.
Mhm.
We try to set a variable equal to the 1th position at this callbacks.
Mhm.
The one position has nothing in it.
Yeah.
So JavaScript will throw an error. It'll say something called index out of bounds. Our index number 1 is out of the bounds of this array.
Yeah.
So, I totally wrong thing. This line code gets run first.
Okay.
So instead of comparing 0 to 1, we say, all right, I is equal to 0. We already know that. We run this on a code. I plus plus, so I is equal to 1 now.
Yeah.
Is 1 less than or 1?
No.
No, that's false.
So it stops.
Yeah.
Now, will JavaScript know? This is how you write it always, and
Yeah.
so it would go execute this.
No,
then
well,
this.
no. It
Or
goes
should you
this,
have written it?
It goes initialization statement,
Yeah.
then body, and then third statement, and then second statement. And
Oh.
if second statement evaluates to true, then we go back to body. And then
Oh,
third
okay.
statement, and then if second statement evaluates to
Yeah,
true, then
because it
body.
could just keep going. Yeah. Okay. Cool. Because if it was the other way, it goes here, 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 but then the other way would be here, 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 and it would just go back. So, but this is the right syntax, right?
Yes.
It's not that you should have written it switched. You wrote it the right way.
I run it the right way.
Yeah. Cool.
Yeah.
Cool. All right.
Alright, so now let's say, the worker receives some update, right?
Mm-hmm.
Let's modify his callbacks list. Let's add him another task that he has to do upon receiving an update, or upon receiving a message. So we're going to say, let's say we have another message called walk to kitchen. I don't know, he's making his boss some coffee or something.
Mm-hmm.
And there's tons of code in here. There's like 20 lines of code, but we
Yeah.
don't have to know that it's call a function walk to kitchen. How would we add that as another task in his callbacks queue, his callbacks list?
Yeah. Did we already make a callbacks list for him?
The class did. The this.callbacks
Yeah.
is available inside of worker.
Okay.
We can't access it, but it exists somewhere in the code. It exists somewhere on the machine.
Yeah. Okay. So we have to kind of add it. We have to type it in here just to plug it in. And then,
Right.
Okay.
The only way we can interface with worker, the only proper way to interface with worker is by calling the onUpdate method.
Mm-hmm.
So we could say worker dot.
What, on update?
Yeah.
And then walk to kitchen
Exactly.
in parentheses. Now, does
No.
this...
And parentheses. Walk to kitchen, we don't invoke it. We just pass in the name of the function.
Okay. Walk to kitchen. Okay. Now, does it exist somewhere? Does this exist somewhere? Where
It does exist on the machine somewhere.
Mhm.
We're just alright. So actually, it remember how this gets set equal to worker.
Mhm.
So callbacks is a property on this.
Yeah.
Therefore,
Callbacks is a property of worker.
exactly. So what
So it's
what
somewhere.
we could do, we could literally just say worker dot callbacks dot push walk to kitchen. We could literally just do that. But there's a reason why you don't want to do that. And the reason for that is we might write a bunch of other stuff in this onUpdate method. Like we might console log some statements, and then we might
Add some stuff that you'd want to
be repeated every
Yeah.
time you would call this function,
Yeah.
every time you call onUpdate.
Uh-huh.
If we didn't add it there, then we would, instead of having write workers.callback.push, we'd also have to write we'd have to write workers.callback.push, and then we have to write console.log this, and we'd have to do write this, write that. Might have 5 lines of code every time.
Yeah.
Here we can just store it in one function.
Cool.
There's also another concept later called property hiding that we don't have to get into, but we might want to create classes where we have methods that do things on properties that are attached to this, but that we don't really want people to know about. So we might have some property that exists on worker, but we don't want people editing that property directly. We don't want people doing worker.prop is equal to 7. We only want people to do things through our methods.
Yeah. And so here is we just, if we ever want to add to the worker.callbacks, we just have to do this. Worker receive update.
Worker receive update does not add anything to the callbacks.
Okay.
Only on update does. On update
Oh,
pushes to
I'm sorry, right here. Yes. Okay. Because worker is equal to new subscriber core. Yes.
Yes.
And so basically, yeah, it becomes this. Then you write, worker dot. And so, okay. Say hi is a function.
Yep.
Right?
Yep.
Yeah, function say hi. And so this is defining this as a function.
Right.
So you put it here.
Right.
Because then that fulfills this. And then, how do we add it to this again? Do we?
That's what this callbacks that push does.
Okay, so
So
then,
we call on
so
update,
worker
which
dot
calls yeah,
callbacks dot push
exactly.
function. So basically, it's saying this function. Okay, so here's the function, and then you put it here. Okay, it's a function. It's good. And then here, it's like basically this function. Push it to callbacks
Yes.
for worker.
Yes.
So it kind of like goes backwards. Very cool.
Now that we have a new task, we have a new callback inside of worker. Let's say we create another message. Const message 2. And again, it conforms to the iUpdate interface. I can't spell update. Is equal to, there's a bunch of properties in there. We don't need to know what they have. How would we have the worker run that new message?
Wait, I'm
Well,
sorry.
let's say-
This
let's
is
say-
under worker, or is this
No,
another
it's like,
thing?
this is another line.
Yeah, okay. Constant message. Okay, const message 2. So you're wait, const. But it subscribes to update. Okay, so then it
Doesn't
equals
subscribe.
to.
This object called message 2
Or
conforms to
It's
the
not
iUpdate
subscribe.
interface.
I keep using that the wrong way. It's conforms.
Yeah.
So the proper way to say is conforms to iUpdate.
Yes.
Yes. Okay. Conforms to iUpdate, and it equals this function or whatever.
No, it equals an object. It equals a
It-
set of
it's
properties.
an object.
It's not a
Yeah.
function.
Yeah.
If the way we know this is not a function is if we were to try to invoke this, like that, it would throw an error. Only functions you can invoke
Yeah.
in parentheses.
And wherever iUpdate is, it has a certain amount of properties.
Yes.
Yes. Okay.
With certain names and types.
Yeah. What? Show me. There's somewhere else where we set a constant worker is equal to. This is an object.
This is, yes, this returns an object. This
Okay.
right here is something called a constructor function, right?
Okay.
Constructor function implicitly creates a new object and returns it, meaning it passes it through the equal sign and sets a value of worker equal to the result of the equal sign.
Okay.
Right, so this is called constructor function.
Well, so this is the object then, or no?
Yeah. This kind of exists here. It has a property called callbacks and has methods called these.
And that is an object.
Yes, this is an object.
Yeah. Okay. So this constant work is equal to this, which just means it takes this object and it applies it to worker.
Right.
Okay.
And
That's
to get-
kind of what I meant.
To get some more terminology, the
Yeah.
class subscribable core defines a constructor function called subscribable core. So that's what we did here. We create a constructor function, JavaScript interprets it, creates another function called subscribable core. That function gets invoked using parentheses, and then the result of that function is this object, which gets returned, which gets passed through the equal sign
Yeah.
and set equal to
Okay.
worker. Or worker gets set equal to it.
Yes. Yeah. Very cool. Okay. So this would be equal to. So, what was your question again? Constant message.
My question is, how do we have worker receive message 2?
How do we have worker receive message 2? Do we know what message 2 says?
We don't need what message 2 says.
Okay.
We just need to call the receive update method on worker.
Oh, we just need to kind of plug it in and then see what comes out. Okay.
Yeah, we just type
Worker
worker.receive
receive
update message 2. Yeah.
Okay. Because that was this, right?
No, that was this.
This. Worker receive update. Yeah. Okay. Because it conforms to iUpdate, and then
When you say it, be careful about saying it. What
Okay.
do you mean by it?
Okay, I'm sorry. So we have receive update.
Yeah.
Conforms to iUpdate or update object.
Update object, which is the parameter, the first parameter of the receive update method. Update object conforms to the iUpdate
Okay.
interface.
Okay.
Likewise, message 2 conforms to the iUpdate interface. And message 2 is passes the first argument into the receive update method.
Yeah. Okay. So worker dot receive. Where's that? Okay. Update message 2, and then that would kick out say hi. Yeah, and we don't care because they both subscribe to this or they both conform to this. We know it's good, and we put this in, and it would should say something. It should say whatever. It should be the equivalent of this right here.
Yes, and then what else happens? Because now we have a new callback added to our callbacks list.
We would. Okay, wait. Well, do we know what order they're in?
We can figure out how we define it. So, alright, so push, first it adds at index 0, and then when you call push another function, it gets added to index 1, and you call push again, it gets added to index 2.
Okay.
So we look at how we define this. Sorry. We look at how we define the for loop,
Mm-hmm.
and we look at the order that we called on update with these functions. Which function will get invoked first? Say hi or walk to kitchen?
Oh, so it would just go. It would go say hi, walk to kitchen, and then message 2, or no?
Message 2 is not a function. Message 2 is just some update object that we actually aren't even using.
Okay.
The worker has to receive some update. They receive some piece of paper in their task,
Okay.
and they just follow some the way we have it defined right now is the
Uh-huh.
worker follows some list of instructions we
Uh-huh.
define in all the update methods.
Yeah.
They just follow it blindly. They don't even really read the message. We can change that in a minute though,
Okay.
if your brain is up for the task.
Yeah. So okay. So the question was.
What order do the callbacks get called?
Yes. Okay. And do we have 3 callbacks?
We have 2 callbacks.
Okay.
We
These
have
are
as
2
many callbacks as we called on update function.
Okay.
Because on update adds 1 callback into the
Oh,
callbacks list.
Okay.
You called update twice, once
Yeah.
here, once here. The first callback that got added to the list was say hi. The second callback that got added to the list
Yeah.
was walk to
On
kitchen.
update.
No,
Oh,
no,
so
no,
this-
no, it was walk to kitchen.
Yeah.
Function,
Sorry. I was.
Okay, I see what you mean. Yeah,
I was. No. I was this. I totally
Gotcha.
missed that.
yeah, my bad.
Okay. So, did we worker receive? Did we do this before somewhere? Worker receive update
message.
message.
Yeah.
Okay, and then in this message, we had these 2 callbacks.
I wouldn't say in this message. In the receive update method, we process the 2 callbacks.
Okay.
Message itself does not contain any callbacks. Message itself contains something we don't care what it contains.
Okay. So does walk to kitchen and say hi? Do they have anything to do with
The message? No, they actually don't. The way we've written our program right now,
Yeah.
they don't have anything to do with the message. We'll change that in a few minutes.
Okay, what are? I'm kind of confused on how message interacts with this.
It doesn't
And
interact.
Okay.
It just the only reason we're passing a message is because the way we've defined the class is that it must contain an argument,
Okay.
or else types will throw an error.
Yeah. Okay.
We'll add the message in a second. So
Okay. You keep going. Because there's probably just some little error. There's probably just one little tiny.
it was a bad example. I shouldn't have had.
No, that's okay. It's probably just one little minus. You know what I'm saying? You can't figure out the entire
Right,
fucking
right.
equation because you missed one minus
Yeah.
sign. Like there's probably
Yeah.
one little thing I'm missing. So just keep going.
In terms of new dependencies per second, we should probably go on to per minute. We should probably go on to another thing.
Okay.
So let's say
Because the more dependencies, the more the better I'll learn it. You mean? What do you mean the dependencies?
yeah. So I'm saying let's say there's a bunch of skills we're learning right now,
Mhm.
and you just learned 11. You just learned 15 of them.
Yeah,
And
they're all
the
just.
16th one is kind of hard for you to learn right now.
Uh-huh.
We might as well just start learning another 5 ones, just
Okay.
to be more efficient. And
Yeah.
then maybe somewhere later down the road you'll understand this one.
Yeah. Okay. Like something that's not. It's kind of like a sidestep rather than a.
Yeah.
Yeah. Cool.
So let's change our function definition for say hi, and let's say now contains a parameter called message. And let's say that the iUpdate interface type is the following. Interface iUpdate. Let's say that the update has a property called time, right? And time is a number between 0 and 24. Let's say it has other properties, so we don't care about those. We could say, hi, I received your message. This would be so weird, like when someone walks in, you say, hi, I received your message at 11 p.m. Yeah, so I received your message at message.time. So if the message passed into say hi contained a property called time, and the time had a value of 11, what would the person say?
Hi, I received your message at 11.
Exactly.
Yeah. Okay.
So now let's say right here we've messaged iUpdate. We have a bunch of other properties, but we also have one called 13, as in for 1 p.m.
Yeah.
When this gets run and receive update, we would see in the console. What do we see in the console?
I received your message at 1.
At 13.
At 13.
Yeah. Because
Yeah.
we'd have to write some logic to transform it from 13 to 1.
Yeah.
All right, cool. So now, let's make our walk to kitchen method contain. Let's redefine walk to kitchen. There should be 2 whiteboards. This word.
Just right in the window. I think somewhere it said don't write in the windows, but you don't have to worry about it.
Alright. Oh, that's my face. Alright, so function.
That's good. It's good enough.
Let's call it walk to kitchen.
Can you see
message?
That's right. What's the matter?
And this is of type iUpdate, right? Messages of type iUpdate. We could say console.log. Let's say it's going to take the worker an hour to walk to the kitchen. They could say, I will arrive in the kitchen. And again, there's lots of other tasks, like the user actually walking to the kitchen. I'll arrive to the kitchen. Arrive at the kitchen. No, I'll arrive to the kitchen. I'll arrive at the kitchen.
I'll arrive in the kitchen?
I don't know, something. I'll arrive something in the kitchen at, let's say, message.time plus 1. So let's say it takes an hour to get the kitchen. The message was sent to them at time 10. They will arrive to the kitchen at time 11. And they're printing that out into the console.
Yeah.
You have to close parentheses. So now our functions, they're expecting a parameter called message, right? Or they're expecting a parameter of the type iUpdate. And they're using that parameter. So now, we are actually going to invoke these functions. We're going to call these functions with that parameter, with the update. This is probably really abstract.
Well, it's okay because they both conform to iUpdate.
Right. So now, let's see if you can follow the chain of logic that's going on.
Yeah.
All these callbacks, they are functions that take one parameter of the type iUpdate, right? When we call the first callback, worker.receiveUpdate, we pass in that message into receiveUpdate. So receiveUpdate gets run. We enter the for loop. We look at the 0th element of the for loop. 0th element, in our case right here, is what?
It's say hi.
Yeah, say hi.
Yeah.
So now, say hi set equal to function to invoke.
Uh-huh.
So we call function to invoke and we pass in one parameter, right?
Yeah.
The one
And
parameter
the parameter
update
is
object.
update object, which
Update
conforms
object
to I
was
update.
message.
Yeah.
So essentially what we end up doing, so when we call
Yeah.
over here it looks as function to invoke update object.
Yeah.
But another way of looking at it is say hi, passed in with message.
Wait, okay.
Or message
I was
passed
following
in
until we came here, and then you went back, but I was just thinking about 13, and I was, for some reason, I was just like distracted by that. I'm sorry. Like reverse like 30 seconds. I was following up until, for some reason, I was fixated on that 13.
So we call worker.receive update
yes.
with message. Message is defined here. Message gets passed into receive update,
Mm-hmm.
and now it's called the parameter update object.
Mm-hmm. Yeah.
We then look at the callbacks list. We access the 0th one up there because I have 0.
Yep.
Worker
Dot
set
callbacks.
function what?
Yeah.
The 0th callback was what?
Is say hi.
Let's say hi. So essentially, what we're doing is we're invoking function to invoke, but in our case, function to invoke is say hi.
Yeah.
So really, we're invoking say hi.
Yeah.
And the parameter we're invoking it with is update object.
Mm-hmm.
But as we know, update object was really
It's message.
message. So really, we're invoking say hi with message.
Now, invoking means plugging in. Like we would
It
plug
means-
plug message in to say hi.
And then run the function.
Yeah.
Run the function means execute all the lines of code inside of the function.
Function. Okay. And say hi needs message, which also subscribes to I
It doesn't subscribe, it conforms.
or conforms. Yeah. Okay. So then.
Essentially, this line of code gets run, and
Yeah.
message has time 13, so what gets printed out is hello, I received your message at 13.
Ah, cool. Okay, so this whole message was just to get the time, then?
Yeah.
Plug the time in.
Right. But the message, we don't know what iUpdate has. It might have 10 other properties,
Yeah.
and then other callbacks we have down the line might interact with other properties. of iUpdate.
Very cool. Oh, and you just built like this whole machine.
Yeah.
Yeah, that's cool. Okay.
Now, I'll just go down here.
Okay, so you could basically do this for like whatever, because message dot time. Okay, time here. It could be message dot location, message dot
Right.
blah blah blah. Okay, and then you can have all these different little machines running that all churn out one giant long answer. Like, hi, I received your message at XYZ time. I went to this location.
Right.
Yeah. Okay.
So what we have in our app is we have. Oh, don't change your camera.
Heyo.
We have some parts of the app that are centered on messages, such as we just changed the color of this node from
Yeah.
red to green.
Yeah.
This item just became overdue.
Uh-huh.
And then we have workers which subscribe to those messages and perform tasks on them.
Yeah.
One of the workers syncs with the database.
Yeah.
Another one of the workers sends a message to another part of the app,
Yeah.
which itself has its own worker, which updates the UI.
Yeah.
So we just have a bunch of workers talking to each other.
Yeah. Oh, so this
Through-
is
through
basically a
updates.
principle that is just fundamental to the whole program.
Yes.
Yeah. Very cool.
Yeah.
All right. See that? Yeah. I like. Yeah. I want to watch the video again because I'll probably like, forget some of it, but I feel very comfortable with it.
Right.
Like I think sometimes that might be half the battle. It's like you relax and you're like, oh no, I get this. Like and you're
Yeah.
like, oh yeah, what about this and this and this. So it's like, if you can't, it's like there's like conscious knowledge that you're conscious of, and there's knowledge that you're like unconscious of. So like, even though if I look at this and I'm like, I couldn't probably repeat all of this again.
Right.
If you went through it again, I'd be like, yeah, you know what I'm saying?
Do you
Like,
want to do like
recall? Go ahead.
an assignment
Yeah.
where 2 weeks from now you present to me like everything you've learned, as if,
Okay.
or to Brian, because Brian doesn't know the code base.
Yeah. Well, I could just try to teach someone. Yeah,
Exactly.
I'll try to teach Brian it or whoever. Yeah. I'll do that.
That'd be cool.
Yeah, because it'll help me learn.
Right.
Because you don't really learn it until you help teach it.
Right.
I like that. Well, there's a quote. It's like, this looks gross. I'm sorry, but it's good. You don't grow until you learn and you're teaching, or like learning and teaching equals growth or something.
Interesting.
It's like a Japanese proverb about like you have to teach to learn it all or something.
So let's finish this up with. So we we have this block of code. We just executed up to this line right here, receive update.
Yeah.
Now we're calling the update method again. We're passing in another function, another callback into a callbacks list. So what is this .callbacks? What does worker.callbacks contain now?
Walk to kitchen, the function,
And
and
say hi.
say hi. Yeah.
And what index is say hi at?
What index?
Of
I
this
update?
info? Index
I don't know what you mean by
index
index.
stands for the number. The
Okay, yeah,
position.
0.
Yeah,
So say hi is 0. Walk to kitchen is 1.
exactly.
Yeah.
All right, and then
Oh, I see. So it's like first he says hi, then he walks to the kitchen.
Right.
Yeah. Okay.
so now we
And
create a new
message
message called message 2. Message 2.
Okay.
It has a bunch of properties. Let's say
Was this all message 1?
message
No.
1 is
It's just time.
just this object here.
Yeah. Message 1 is just time, right?
Well,
Message
it,
is just
it
time.
contains other properties.
Okay.
We just haven't revealed what they are.
Yeah. Okay. Okay. So message 2.
And let's say worker, he sits around for a few hours afterwards. He gets another message at 3 p.m. Say it's time 15. Okay, so now we say worker. The boss goes on his desk, he slaps a new update, a new message. Worker invokes receive.update with message 2. What happens?
Okay. So where is receive update? Okay, so receive update. Message 2 has to conform to I update. And worker. I feel like whatever the. Okay, so I'll go back to what we define worker as. So worker was this, and so where's the? Did you const update? No, const worker equals new subscriber. Now our worker update worker dot on update say hi, and worker dot on update walk into kitchen. Those are both underneath this. Do you know what I'm saying?
These are different lines of code. This is one line of code. This is another line.
Okay.
This is another line.
Okay.
These are all different statements.
Yeah. Okay. So
this whole time you've been confused about that?
yeah. Well.
Oh shoot.
Not
So
really.
alright, so there were no open brackets here.
Yeah.
So this is invoking the function.
Yeah.
This is like defining a class. If you never see squiggle brackets,
Yeah.
that means like
They're all
lines
different.
of code are separate. They're not
Yeah.
necessarily related.
Well, that's okay. No. I wasn't like really. I didn't have a lot rooted in that idea, but
Alright,
okay,
cool. I was
anyways.
hoping you weren't like hopelessly confused.
No. Okay, so this one. Yeah. I don't know. Give me a second. So we receive.
Dude, it's interesting. I wouldn't have even thought of that as a potential.
Because you know what I'm saying. You
It's
know so much.
No,
that,
it's like a result of like dependencies that you didn't learn, and it's like a conclusion you reached.
Yeah. What do you mean?
So you know how like we've been mapping out new skills as like the result of
Yeah.
dependencies. So
Yeah.
we'd say this is a conclusion.
Yeah.
It's like the void of you knowing nothing
Yeah.
kind of imaginarily created some dependencies and created a conclusion.
Yeah.
A false conclusion.
Yeah.
Yeah, because
Yeah.
I didn't teach you stuff correctly.
Yeah. That's cool. Okay, so wait. Worker dot receive dot update. Okay, so okay. Message 2. Oh, well, this is just like kind of like it's just like an update. It's just like, oh, this is a new thing. So it would just say, hi, I received your message at 15.
Let's trace through the code line by line.
Okay.
So receive update gets invoked.
Yeah.
Which means receive update on this, which is the worker.
Yeah.
It's called.
Okay, so then it would go. It would invoke whatever. Let's see, message 2 is. Let me struggle with it. So, would it be that message 2 is the. Oh, wait, where's message 1? Where's message? Message is here. Okay. Right?
There's a much easier way to.
Alright, you just tell me.
You just want to. you don't want to start generalizing. You just want to execute code statement by statement.
Okay.
So receive.update gets executed.
Mm-hmm.
So what that means is the first line of receive update gets executed.
Mm-hmm.
The first line is letting I equal 0.
Mm-hmm.
So I equals 0. We enter the body of the loop.
Okay.
Now we set function to invoke equal to the result of this dot callbacks at position I.
Okay.
What is this dot
So
callbacks?
it's worker.callbacks, position I.
Yeah.
And so position 0 is say hi.
Exactly. So function to
Yeah.
invoke is say hi, right? So now let's
Yeah.
go to this statement of code.
Yeah, okay, so function to invoke update object would be message 2?
Yeah. More specifically, update object is message 2.
Yes.
More specifically, say hi gets called with message 2.
Yeah.
Yeah.
So it says hi, I received your message at 15.
Yes.
Right.
Now.
Okay. I knew the answer, I just didn't know the follow it.
Right.
Yeah. Okay.
So
Okay.
let's continue executing lines of code.
Yep,
So
yep,
now
yep, yep.
after the end of the for loop, the body we go to where?
Go to the end, and then you would add 1,
Yeah,
and then it would go to the next.
Yeah. Now we go here.
Okay, yeah,
So it's
so
1 less than 2.
1 is less than 2.
Alright. So
So
now
we
we
go-
go here.
So then we go invoke function worker.callback position or I equals 2
I
or
is
I equals
1.
1, and then that would equal I'm walking to the kitchen or something. Where is it?
No. It just equals the name of the function.
Walk to kitchen.
Yeah.
Yeah. Okay. So then we do function to invoke would be because yes. Okay. So function to invoke.
Is
The
walk-
function to invoke
walk
is
to kitchen.
where the
Walk to kitchen.
yeah okay
So messy.
walk to kitchen, and then the update object
This is the comment. Yeah. Update object is
is message 2.
exactly.
Yeah.
message 2.
I was just mimicking it, so it's
Yeah.
it's walk to the kitchen message 2, and then it would spit out. What did that spit out? Do you
Well,
remember?
let's
Did we
look
say
at the walk to kitchen function. Where is that? It's defined over here.
that? Okay. Walk to kitchen. Yes. Okay. So then it would say, I will arrive in the kitchen at, and then it would be time at 16.
Exactly.
Nice. Yeah.
Yeah.
That was good. I needed that second one.
Yeah.
Like I understood it, but that solidified my understanding, so that's good.
It's like a absolutely necessary skill to be able to trace through code statement by statement and
Yeah.
actually understand what goes on.
Trace the code, yes, tracing through code.
Yeah.
And what you were saying about how like we should stay here instead of going on, I think that was a good idea. Yeah, because I learned how to trace through the code. Because I just feel like, oh yeah, that's the answer, but it's like,
Right.
well, you can't assume. You have to kind of go through.
Exactly.
That's sweet.
All right. So the reason we were going over this
Yes.
is because we were editing something over here.
Yes.
I totally forgot what we were doing at this.
All right. Well, let's. Can I pee and then out?
Yeah.
Like we can edit it.
Yeah.
That took 2 hours.
Yeah.
That's crazy.
But
It
you-
doesn't seem like 2 hours.